In 2018, a machine older than most people alive flew straight into a wall of fire at the edge of the solar system, 50,000 degrees, and it came out the other side completely unharmed. That machine is Voyager 2. It launched in 1977, and right now it is 21 billion kilometers away, falling through the dark past the edge of everything the sun can touch. 21 billion kilometers is a number that means nothing until you try to picture it. Light is the fastest thing in the universe, and even light takes more than 19 hours to get there. If you tried to drive it at highway speed without ever stopping, it would take you over 20,000 years. From that far out, the sun isn't a warm disk in the sky anymore. It has shrunk to a single brilliant point of light. But that wall of fire? That is the boring part. Because the strange story of Voyager isn't about anything it found out in deep space, it is about what happens every time it tries to call home. 3 separate times, the line has gone dead. And one of those times, it wasn't the probe that went silent. It was NASA. This is the part of the story that never makes the headlines. So let's go through it, because almost none of it is what you would expect. Voyager 2 launched in the summer of 1977, and for the next 12 years, it pulled off the greatest sightseeing run in the history of space travel. Jupiter in 1979. It photographed a single storm bigger than our entire planet. Saturn in 1981. Then it went where nothing from Earth had ever been. Uranus in 1986, where it discovered 10 brand new moons in a single flyby. And Neptune in 1989, where it clocked winds screaming at 2,000 kilometers an hour. The fastest in the solar system. 4 planets, 1 machine. Nobody had done it before, and nobody has done it since. In fact, here is something to sit with. Voyager 2 is still the only spacecraft that has ever visited Uranus or Neptune. Basically, everything humanity knows up close about 2 entire planets in our own solar system comes from a few hours of one probe flying past in the 1980s. That's it. That is all the close-up data we have. And it did all of this on technology that is almost comically old. Voyager's onboard computer holds about 70 kilobytes of memory, total. Your phone has something like 1,000,000 times more. It is flying on 1970s hardware running code so old that when something goes wrong today, engineers have to dig through 40-year-old paper manuals just to remember how the thing works. And here is a detail that sounds like a misprint. This machine was only built to last 5 years. 5, just long enough to photograph a couple of planets and quietly die. It has now been running for 48. The most successful deep space mission in history was technically supposed to be over back in the early 80s. But at Neptune in 1989, it did one small thing that matters more than anything else in this video. To swing past Neptune's frozen moon Triton, it let the planet's gravity fling it downward, below the flat plane where all the planets orbit, angling it south under the entire solar system. Remember that turn, because that single move is the reason for almost everything that goes wrong later. Oh, and it is carrying cargo. Bolted to the side is a golden record, an actual gold-plated disc with the sounds of Earth pressed into it. Whale song, thunder, 90 minutes of music from around the world, greetings in 55 different languages, even the brainwaves of a woman in love. And on the cover there is a map, drawn from 14 pulsars. It shows exactly where Earth is, and even when the probe left. It is a message in a bottle, engineered to survive. Out in the vacuum of space, that gold disc could stay readable for 1 billion years. Hold that thought because it comes back at the very end. November 5th, 2018. After 41 years of flying, Voyager 2 reached the strangest border in the solar system, the heliopause. Picture the sun blowing a gigantic bubble around all of us, a balloon of solar wind and magnetism about 18 billion kilometers across. The heliopause is the outer skin of that bubble, the exact line where the sun's wind finally dies and true interstellar space begins. And that border is on fire. The headlines called it a wall of fire because the plasma out there measures somewhere between 30,000 and 50,000 degrees. But here's the counterintuitive part, the bit almost everyone gets wrong. That heat cannot melt anything. Out there, the gas is so unbelievably thin, just a few particles floating in a space the size of a room, the temperature only describes how fast those few particles are moving. There's basically nothing there to actually burn. So Voyager didn't slow down, and it didn't melt. It slid straight through the hottest boundary in the solar system and barely noticed. And what it found on the other side breaks your intuition all over again. You would think that once you leave the sun's bubble, space would get emptier. It is the opposite. The raw interstellar medium out there is actually denser than the edge of the sun's bubble, and the cosmic radiation pouring in from the rest of the galaxy jumped the instant Voyager crossed. For the first time ever, something from Earth was sitting in the real unfiltered space between the stars, and reporting back. And this is where it stops being just cool and starts being seriously important. Voyager 2's plasma sensor was still alive. Its twin Voyager 1 had reached the same boundary back in 2012. But that probe's plasma instrument had been dead since 1980, so it went through half-blind. Voyager 2 crossed with its eyes wide open, which means it captured the first direct measurements in history of the boundary between our sun and the rest of the galaxy. Results published in the journal Nature Astronomy in November 2019. Real data from the only machine that has ever felt the edge of the solar system from the inside. And while we are here, think about how faint Voyager's voice actually is. It transmits with about 20 watts. That is less power than the light bulb inside your refrigerator. And after crawling across 19 billion kilometers of space, by the time that signal reaches Earth, it is faded to less than a billionth of a watt. To catch it, NASA uses a network of enormous dishes, some of them 70 meters across, tuned to pull that one specific whisper out of the roar of the entire universe. The fact that we can hear it at all might be one of the most impressive things our species has ever pulled off. Which is exactly why the real danger to Voyager was never the wall of fire. Out there in the dark, to stay alive, this machine needs one thing, not fuel, not warmth. It needs someone on Earth to be listening. And 3 separate times, we stopped. Here is a fact that sounds completely fake. Out of every giant radio antenna on the entire planet, exactly one can send a command to Voyager 2. Not a handful. 1. A single 70-meter dish called DSS-43 in Canberra, Australia. Why only one? Because of that turn at Neptune, diving south under the solar system. From down there, not a single antenna in the northern hemisphere can even see it. Only the southern sky can reach it. One dish, one continent, one planet. And in March 2020, they had to switch it off. Its transmitter was 47 years old and needed a complete rebuild, an 11-month job. Which meant that for 8 straight months, there was physically no way for anyone on Earth to send Voyager 2 a single command, as NASA spelled out in its own update at the time. But here is the part that is actually wild. They could still hear it the whole time. Smaller antennas kept catching its signal every single day. They just couldn't talk back. As the mission's manager Suzanne Dobb put it, "We've always been talking to the spacecraft every day. They simply couldn't send it a command." Finally, in late October 22, they powered up the rebuilt dish and sent a test. The signal took 17 hours to get there, and the reply took another 17 to come home. A full day and a half for one hello. But it worked. That was the longest silence in the mission's history. Until, 3 years later, it happened again. And that time, it was our fault. July 21st, 2023. A routine set of commands went up to Voyager 2, and buried inside was a mistake. It nudged the probe's antenna just 2 degrees away from Earth. 2 degrees. Hold your fingers up 2 degrees apart. It's nothing. But Voyager was 19.9 billion kilometers away by then. And across a distance that absurd, 2 degrees is a canyon. The antenna was suddenly aimed at empty space, cut off from Earth in both directions at once. No command could reach it, and nothing it transmitted would ever find its way home. And the probe had no idea anything was wrong. That is how unforgiving these distances are. Remember, every command takes about 19 hours just to arrive. So there is no steering this thing in real time. Every instruction NASA sends is a bet placed almost a full day in advance, and they don't find out if it went wrong until the next day. A 2-degree slip, and the most sensitive antennas on Earth are suddenly shouting into an empty void. Now there was a safety net. Months away, Voyager was programmed to automatically swing back toward home on its own. But months is a long time to sit and wonder whether the most distant machine ever built is already dead. So they didn't wait. On August 1st, the Deep Space Network went looking and found it. A single faint carrier tone, a heartbeat. Alive, just aimed the wrong way. So on August 4th, they tried something that should not have worked. They pointed that Canberra dish at the empty patch of sky where Voyager was drifting. They turned it up to full power, and they fired one command into the dark. An interstellar shout, loud enough that maybe, just maybe, the edge of it would clip the misaimed antenna. That shout traveled 18.5 hours, and it landed. Voyager turned back toward Earth. The whole sequence documented in NASA's mission update that August. And it isn't only Voyager 2 breaking down. Its twin Voyager 1 spent 5 months across 2023 and 2024 sending home pure gibberish, all because of one corrupted chip. And then, in 2024, it shut off its own main transmitter for the first time since 1981. 2 machines out in the dark, both starting to fail at once. Which brings us to the countdown that is running right now. Both Voyagers run on the same thing. A slowly decaying lump of plutonium that turns its own heat into electricity. And every year, each probe loses about 4 watts of power. Doesn't sound like much. But after nearly 50 years, there is almost nothing left. So NASA has been doing something slightly eerie to keep them alive, switching them off, one instrument at a time. Voyager 2's plasma detector, off in 2024. Its charged particle instrument, off in 2025. Its cosmic ray sensor, scheduled for this year. And Voyager 1 lost another instrument just this past April. 7 of the 10 it launched with are now dark. You can actually follow this in real time. NASA publishes an update every time it powers another instrument down, and they are fighting this hard for a reason. The 1 or 2 instruments still switched on are sitting somewhere nothing else humanity has ever built has reached. They are sending back the only readings we have from true interstellar space. Every extra month is data we can get from literally nowhere else. Which is why, right now, in 2026, NASA is attempting a last-ditch gamble to squeeze out more time. They are calling it the Big Bang, swapping a whole stack of old power-hungry systems for leaner ones all at once in one risky move. And remember, this is 1970s hardware. Run with controls most of the people who designed them aren't around to explain anymore. They are testing it on Voyager 2 first, because it has a little more power to spare. If it works, they will try it on Voyager 1. If it fails, they could lose the spacecraft entirely. And this is not history. It is happening as you watch this video. So, count them up. 3 silences, the 8-month repair, the 2-degree mistake, and the twin slowly losing its voice. Every single time NASA clawed them back, a rebuilt dish, a lucky heartbeat, an interstellar shout across half a day of space. But there is a 4th silence coming, and this one is different. Somewhere in the 2030s, maybe sooner, the plutonium simply drops too low to power anything at all. And that is not a repair, or a mistake, or a broken ship you can fix. That is just the end. When it arrives, there is no rescue, no shout loud enough. But here's the fact to leave you with, and it is a strange one. When Voyager finally goes quiet, it does not stop. There is nothing out there to stop it. It just keeps gliding at more than 50,000 kilometers an hour through the empty space between the stars, still carrying that golden record, still holding its whale song and its hellos in 55 languages, and it is nowhere near done leaving. It won't even clear the outer edge of our own solar system, the vast shell of icy rubble called the Oort cloud, for another 30,000 years. It won't pass anywhere near another star for 40,000, and long after our own sun has swelled up and swallowed the Earth, that little gold disk will still be out there drifting in the dark. Quite possibly the last surviving piece of evidence that any of us were ever here at all. Not bad for a machine that was supposed to last 5 years. If you want to know what actually happens to everything out there in the end, including our own sun, there's a video on your screen right now on how every star in the universe dies. Go find out, and I will see you in the next one.